Okay, let's talk about delete node in the BST. So you're given the root node reference of the BST and a key. Delete a node with a given key in the BST. Return the root node reference of a BST. So if you find a key in the BST, you basically have to remove. And you want to basically the deletion can be divided into two stages. Search a node to remove. If a node is found, delete. And this is how it is. And so this is pretty much like searching a node in the BST, and then if you find it, and then you delete it. Okay, so I'm gonna write it right now. So if the root equal to null, we can just return null. Like this is no, I mean there's no BST. So if you find it, if the root.val equal to key, if you find it, you do something. If you didn't find it, then you can either go left or either go right. So how do you actually go left? You want to say else if root.val less than key. Sorry, root.val greater than key. Then you go left. Delete no root.left key. So what it meant is if the root value is 5 and the key is 3, then you have to go left, right? Root value is 5 and the key is 3, you go left. And there's another situation, go right. If the root value is 5 and the key is 6, then you go right. So almost exactly the 10, right. And you will just return root. Now let's think about what you should do for the node you found. If you found this node 3, if you have a value on the right, you take it. Otherwise you take the left one. So you are going to say if the root.left is equal to null, you take the root.right, right? And then if the root.right equal to null, you take your left. This is how it is. Like if you find it and you want to replace one of them, right? And imagine that you don't have children on the left, then you take you don't have children on the left, right? So you take the right children. So you will replace 3 and 4. Imagine there's no 2. Okay. Now, if you do have both children, right? You need to find the minimum on the right subtree. So you still have a valid BST, right? So I'm going to say min equal to get min on the right subtree. So how do I actually find this? So I'm going to say public tree no get min, and then tree no, and then I'm just calling no. So I will have to keep traversing this node on the left subtree. So well, node.left is not node. It keeps walking, and it keeps searching on the left, and then you just return no. And this is pretty much it. So if you find the minimum, then you can replace. So root.val. So I still need this. So I still need 3, right? I mean the spots, the space 3. So I'm going to replace the value. So I'm going to say root.val equal to min.val. Then I will say my right, root.right, will have to delete. So I'm calling this function. So I'm going to delete a node for the minimum, right? I want to delete a minimum node. So I'm saying min. Oh, sorry. So root.right and min. So key is min, right? So I starting from the root.right, which is my root, recursion root, and then which one I want to delete is a min. So this is the node I want to delete for the minimum, the minimum I want to replace, and this will be the solution. And they just run it. I think true min. Okay, so this is min.val, I think. Yes, min.val, sorry. You are going to replace a key, and this key has to be a value. So it has to be an integer. And they just run it. Sorry for the mistake. And yeah, this will be it. So what do you think about time and space complexity? So for time, you are basically traversing your tree log n time, because when you find, you are going to split is either right or left, right? Every single time if you're traversing your route, right? So that would be log n, right? The height of the tree, and the space will be constant. Yeah, you're not generating space. The only thing is you have to find the minimum and then you replace. And the time is actually like if a key is 3 and then your root is 3, right? You go left. You don't need to check the right. So that would be log n, right? And then that would be a solution for the time and space. So time is log n, space is constant, which is all of 1. And if you if you think it's helpful, then press a like, subscribe if you want it, and then leave a comment if you want. And I will see you next time. Bye.